Hello, decision makers. Welcome back to Superposed. My name is Aiden Lewis, and everyone's wildest dreams just came true. I figured out how to be on YouTube. So not only can you experience my melodious voice, but you can also witness what some have proclaimed to be superhuman beauty. Not my words. And so here's the decision of the day. How nerdy are you willing to go? Because today we're diving headfirst into the intricate, beautiful, incredible world of quantum cognition. As a self-proclaimed turbo nerd, I hope to relay just how elegant and awe-inspiring that quantum cognition truly is, while also translating the key findings into stories that we can all appreciate without a background in physics or psychology. So if you'll allow me to share one of my core passions in life, please sit back, relax, and get a little bit nerdy as we venture into the forefront of cognitive sciences. Now, today I'll be pulling information from a good selection of sources that are, of course, linked below, but I will mainly focus on a 2022 review paper, and a review paper is just a research paper that summarizes the findings of dozens, if not hundreds, of other papers, so it saves you a lot of time. And it's titled simply Quantum Cognition by Dr. Emmanuel Pothos and Dr. Jerome Bussmeyer, two of the major titans in this field. And to give a little roadmap for today, here's what we're going to be covering. Number one, we'll discuss what quantum cognition is and why we need it. Number two, we'll talk about some of the applications of quantum cognition. Number three, we will talk about the concepts behind quantum cognition and how they work mechanistically. And these are going to get into our four pillars that we love so much: superposition, interference, and contextuality. And then we will finish up with our fourth pillar, non-communicative effects, and the real frontier of what quantum cognition is looking to study. And so the very first question that we need to ask ourselves is, what is quantum cognition even, Aiden? And the answer is that quantum cognition is simply a modeling framework that is formed by quantum mechanics and allows for a better handling of uncertainty in decision-making and cognitive processes. It formalizes explanations to well-known logical fallacies, which we'll cover, and it unifies different fields in cognitive sciences and different cognitive models, which we'll call the classical models, under one umbrella, and lead us to make new predictions to delve deeper into the machinations of the mind, which is what we're all interested in. All that's to say is that quantum cognition is a new way to model cognition that explains, unifies, and illuminates previously disjointed knowledge and processes. The very second question that we'll ask ourselves is, okay, that's cool, but why do we need quantum cognition in the first place? And the answer simply comes down to the fact that life is inherently uncertain. There's an inherent probabilistic nature to our lives, meaning that humans have to navigate a very uncertain, very stochastic environment in order to make decisions not on certainties, but on probabilities. Now, before quantum cognition came around, researchers were using what are called heuristics and biases and other Bayesian-type modeling in order to really describe how humans handle uncertainty in our environment in order to make decisions. But at best, these classical models simply are just disjointed observations that hold empirically, cobbled together, and then impose some sort of uncertainty on top of it. Whereas quantum cognition handles that uncertainty as a mechanism of the processes themselves. So it natively handles that uncertainty in probabilistic nature. Due to not being able to handle the inherent stochastic nature of our environment and decisions, these classical models, while they do a phenomenal job and have for many, many years, their resolution just isn't that great. And also they're pretty siloed into their specific realm of what they're trying to describe. Whereas quantum cognition, one, it has better resolution because it handles the uncertainty natively, and then it also replicates what we're seeing with some of the best like Bayes models, and it makes these descriptions more coherent under a single framework. And in my mind, this makes quantum cognition more fluid and adaptable. One, providing deeper explanations into what we already know, and two, being able to be applied to different domains of research. Now, to think of this difference between classical models and then quantum cognition modeling, think of trying to paint a portrait of yourself. Now, in one of these portraits, you're going to use only dots or little stipples of paint. And in the second, you're going to use full brush strokes in order to paint yourself. The stippling is like classical models. You can get really good resolution on a really small subset of your portrait, but looking all together, it looks more like a conglomerate of these different disjointed dots, whereas a fluid brush stroke, or the quantum cognition modeling, provides more refined detail and a better picture overall. But honestly, it may not matter because I can't paint anyways. And so now that we've seen a little bit about what quantum cognition is on a conceptual scale, let's look at some of the applications of quantum cognition. And so one of the first things that you want to do if you're looking to be successful in the sciences and business, etc., or as a podcaster or substacker, check out the Superposition Substack, is you want to find a niche or a problem, and you want to be able to provide solutions to that problem that people haven't been able to provide previously. And so how quantum cognition got its name is that it provided some of the first explanations coherently to what are some of the most famous cognitive fallacies or paradoxes. Now, we all know that humans are simply irrational creatures. We make decisions that sometimes don't make sense. We are spontaneous. We sometimes lead with our emotions rather than our head. And so one of the issues that classical models has is that it assumes that we make decisions that should be what are called normative or based on some rational baseline. And so any deviation from that is deviation from the baseline and therefore abnormal or irrational. And anyone who's ever watched a video of people throwing chairs at a Waffle House knows just how irrational we are. But this irrationality isn't necessarily abnormal. In fact, many of us make irrational decisions on a daily basis. And so quantum cognition takes this not as a flaw or a defect in our decision making, but actually a product of the same system that's going on under the hood. And so there's really two main cognitive paradoxes that humans consistently produce that quantum cognition explains natively. And these are the conjunction fallacy and the disjunction fallacy. We're going to start with the conjunction fallacy. And so I'm going to colloquially name this as the Linda problem. And if you've ever sat through one of these before, don't spoil it for the rest of us. This was demonstrated in the 1980s by Daniel Kahneman and Amos Tversky, and it goes something like this. And feel free to contemplate your answers as we go along. Linda is a 31-year-old, single, outspoken, and very bright. She majored in philosophy, and as a student, she was deeply concerned with issues of discrimination, social justice, and also participated in anti-nuclear demonstrations. Now tell me, which is more probable? That 1, Linda is a bank teller, or 2, Linda is a bank teller and is active in the feminist movement? Now, if you're like most people, including me and everyone who I've talked to about this problem, is that you probably said number 2 is more probable, that Linda is a bank teller and also active in the feminist movement. But this is actually very, very wrong, simply because bank tellers are a pool of people, and then feminist bank tellers are a subsect of that pool of people. And so saying that it's more likely that Linda is a subset of the pool of people rather than just being in the pool of people is a logical fallacy that has been reproduced over the years ad nauseum. And so quantum cognition researchers said, well, if this is a reproducible result across the board, then this must be a product of some cognitive process of our own calculating of probabilities. And we're going to examine in our mechanisms section coming up just how this calculating process works. But just know that quantum cognition does in fact have a native solution to why we think that Linda being a bank teller and a feminist is more likely than her just being a bank teller. And so this explanation also goes along with what is called the disjunction effect or the disjunction fallacy. And if you ever played the prisoner's dilemma, then you've come into contact with the disjunction effect. The prisoner's dilemma is a game that follows. And again, feel free to contemplate your own decision in this scenario as well. Imagine that two accomplices are arrested and placed in separate interrogation rooms with no means to communicate. The police offer each accomplice a deal. You can either, one, betray or defect, and if one confesses and implicates the other, the confessor goes free while the partner serves a 3-year sentence. Your other option is to stay silent or cooperate, and if both remain silent, they are charged with a lesser crime and serve just 1 year. But if they both defect, or there's mutual betrayal, then they both serve 2 years. This means that a person should want to defect and go free if they don't know what their partner is going to be saying. If they don't know if the partner is going to confess, then they should want to take the best deal for themselves and go free. That's what logically we would all do. However, this also isn't the case, and people choose to stay silent or cooperate when they don't know what their partner is going to do, instead of taking the best deal for themselves, which is irrational because they are risking getting the worst sentence in order to, cooperate. It's just irrational when they should be trying to get the best sentence for themselves. And again, we will cover how quantum cognition explains this irrationality, but think about why people evolved to make irrational choices. Surely there's a reason, a process, at very least, to cause this discrepancy over time. Otherwise, we wouldn't be able to reproduce these results. This wouldn't be a generalizable study, but in both cases, both the Linda experiment and the prisoner's dilemma, the conjunction fallacy and the disjunction fallacy, these have been repeated over and over and over again. And so what causes this? Let me know in the comments. And I'm just going to go quickly through some other applications here so that we can get to the mechanisms of quantum cognition. But from a research standpoint, the quantum cognition does a really good job of giving us the tools in order to test how changing different elements of a decision changes the outcome. So this allows for more rigorous research in the decision sciences, and it allows for potentially better predictive functions of saying, okay, here's a decision scenario that a person is going through. What is the likelihood that they choose X outcome? And in addition, talking about the resolution again, quantum cognition also allows for us to take different pieces of the context or see how internally the interference that we experience when making a decision mechanistically works as well, gaining deeper insight, more granular understanding of how people make decisions. Another really interesting topic in quantum cognition is being able to better model socially or in group circumstances how people make decisions. And this is another product of being able to stack different quantum layers on top of each other. So in each person, there's a quantum decision going on, and then each person can be represented as a particle in the decision space with the spin, velocity, etc., being representative of their internal decision. Those then aggregate over the whole group or social circumstance into the collective group decision. And so we're just starting to see this in the literature right now. It's really, really interesting. And it's something that really hasn't been able to be done before quantum cognition. Think about modeling people during a election cycle. How does the information produced change the superposition, not only of people's internal states, but the superposition of people's decision across a social group? Now think about like in 2024, when there was the attempted assassination of Trump. That is a piece of information that enters the context and changes the distribution of people who are going to vote either Republican or Democrat in that case. Quantum cognition gives us the tools to then understand how that information is going to shift the superposition of people and potentially gauge what the outcome of group decisions like elections are going to be. And there's also a company that I'm going to just shout out here that's actually using quantum cognition to inform its own development of machine learning models right now. And it's called Cognitive, spelled with a Q. And this company is specifically focused at using quantum cognition to make better machine learning models for decisions in the financial sector, or better being able to compact data for LLMs. And really, it's all revolving around how, in our minds, we are using quantum architecture in order to model information and then give outputs or decisions based on that information. It's a really cool company. It's up and coming. Definitely want to give them a shout out here. All right, it's game time. Going to get into mechanisms, and we're going to talk about 3 of our 4 pillars: superposition, interference, and contextuality here. All right, I'm going to give the quantum definition here of superposition and then make more concrete and relatable with an example following it up. And so the superposition is represented by a state vector lying in a vector space, and the superposition state vector is a combination of n number of vectors that represent the magnitude of different aspects of a person's mental state. The state vector is then compared to how different decision outcomes are represented in the space, and if the superposition is decided to align with one of these decision outcomes, the state vector collapses to align with the decision outcome, a process called ontic resolution. And that was a little painful. Whenever I say vector here, I want you to think of a force. So like gravity or the winds or you pushing a sled, etc. And so the superposition state vector is just a combination of all the mental forces in our own decision system, cognitively. And so here's what I think to be a more intuitive way of thinking about this. Imagine I give you a ball of string, and I take one end and I tie it to a tree. And next, I draw an XY coordinate plane, or a box, with that tree at the 0 point, or in the bottom left corner. I then tell you you're going to walk a certain distance and direction from the tree within the box. And when you feel like you are in a good spot, we're going to measure that string and measure the angle of the string, and we're going to compare it with our chart of decisions. And if you feel that the decision that you closely align with is feeling good for you, then feel free to move it to exactly that, and that would be your decision. So let's take the case of Linda. I tie the string to the tree, hand you the ball of string, and I tell you how far up you walk on the y-axis, or let's call it north in this case, is how much you believe Linda is a bank teller. And how far you walk right, or east, is how much you believe that she is a feminist. Now, you can't walk in 2 directions at once. So I tell you to average out these superposed beliefs by finding a space in between that closely aligns with the average of these 2 beliefs in your head, or these 2 vectors. So we send you on your merry way, and we find that you and everyone else who's out in this bizarre experiment have found a point where you have the string that is of some length and of some direction from that tree. We can compare it to our chart of aligning decision outcomes, and sure enough, most people walk closer and longer to the feminist side than to the bank telling side, because they believed it to be true. Not because of what is statistically it should have been, but because they believed it. And so most of these people closely aligned in our book of decision lengths and directions to Linda being both a bank teller and a feminist, and therefore they choose that seemingly irrational choice. But the Linda experiment's a very simple experiment with only really 2 variables. What happens if we add more variables in decision, as we know that real-world decisions are pretty complicated? Now, I've written a lot about this in the Superposed Substack, shameless plug, so my apologies if you've already read my thoughts on this matter, but I like to represent the superposition as a pool of water that you can control the waves in. You can make the waves bigger or smaller based on how much, in this case, you believe a certain variable is true. And you can do this for all the overlapping beliefs or the different vectors in the state space. And you can make a sophisticated waveform where one or potentially a few areas of that waveform are going to be higher, or they're going to be peaks relative to the rest of that wave. And then we're going to take a picture of our beautiful waveform. We're going to compare it to a catalog of decision outcomes to see which it closely aligns to. And if one picture is similar, you can decide to form the wave to exactly like the book and fully collapse the superposition waveform to be that decision outcome. Now, both of these mental models have their strengths and weaknesses. And if you have a way that you like to think about this process, I'd love to hear about it, because this translation of technical, really complex concepts into clear frameworks that we can all work with is just so important. Now let's get into our second pillar of quantum cognition. And now that we have an idea of how to think about the superposition, let's dive into the process of interference, which is a very quantum concept that I believe we can all feel whenever we make a decision. And in the example of the ball and the string attached to the tree, interference occurs when we're asked to average out or combine or to find a spot that feels right, which produces a subjective length and a subjective direction of your state vector string. The strength and direction of your beliefs about Linda are going to cognitively slam together and interfere to produce a combined outcome that is different than either would be separately. In the example of our pool of water, interference can be seen when one belief wave collides with another belief wave to make a combined waveform that is different than either of the two starting waves. And over many, many beliefs that overlap of a complex decision, the final waveform is going to be a construction of all the different subwaves. And just as a technical note here, when two waves collide and their peaks collide, they're going to make a larger peak, or when two troughs collide, the low parts, they're going to make an even lower trough. And this is a process called constructive interference, whereas if you get a peak and trough slamming against each other, that's going to be destructive interference, and it's going to be flat. And then you have the whole spectrum of interactions in between. So I'm going to give you a couple scenarios here to feel this internal interference. For all of these, imagine that you're sitting at your desk, you open up your email, and you get a job offer, and it's your decision whether or not to accept that job offer. Here's scenario one. Congratulations, decision maker. Your application is superposed, has been accepted. I was very impressed. Please review these details and kindly send me your decision in the next 5 minutes. I'd like to give you twice the salary you asked for. You can work wherever you want, remote or in office, and you get free healthcare for your whole family. The decision is in your hands. Here's scenario two. Congratulations, decision maker. Your application is superposed, has been accepted, and I was very impressed. Please review these details and kindly send me your decision in the next 5 minutes. I can only offer you half the salary you asked for. You have to commute 2 hours one way in traffic to the office, and we do not offer a benefits package at this time. The decision is in your hands. Here's scenario number three. Congratulations, decision maker. Your application is superposed, has been accepted, and again, I was very impressed. Please review these details and kindly send me your decision in the next 5 minutes. I would like to give you twice the salary you asked for, but you have to commute 2 hours one way to the office. However, we do have a pretty good insurance plan for you and your family. The decision is in your hands. Hopefully what you observed is that in the all good scenario one, the decision became easier as your evaluation of the different information positively constructed to bring you closer to accepting the offer. But in the all bad scenario two, you felt the negative constructive interference pushing you towards not accepting that offer. And in the mixed scenario three, you may have felt a destructive interference between the good salary and the bad commutes, and depending on your evaluation of the health plan, may have gone one way or another, depending on the magnitude of all the different interference that is going on. And so with that, let's get into our third pillar, contextuality. And as we've seen in previous analysis episodes, contextuality is a very important factor in quantum cognition for two reasons. Those reasons are one, that the context actually sets the scope of the superposition, and two, context plays a significant role in the interference that occurs between the different superposed decisions. To put this to an example, let's say that you're going to the store for shoe shopping. Now, theoretically, every shoe in that store, and even then some of you could choose to be barefoot or wear hats on your feet, etc. All of those are in the theoretical superposition, but you're already going in with an extremely narrowed set, being one, your shoe size, which is size 12 for me, and then two, what type of shoe that you're looking to purchase. let's say a running shoe. And so already you've taken the theoretical maximum of every shoe in the shop and then some, and you're already down to size 12 men's running shoes, if you're like me. But additionally, there's other contextual factors that are going to change how my different internal interference when choosing different size 12 men's running shoes is going to play out. And so think about this as the difference between making waves in a bathtub versus making waves in the trunk of your car. For example, let's say that your favorite color is red because it makes you run faster and you're biased towards choosing red shoes. However, the only pair of red shoes available is from a company that you've had a bad experience with. And because of this context, you're probably not going to go with the red shoes even though you would normally pick red shoes. You might actually go with a pair of blue shoes from a company that you've had great interactions with. And I'll just take this moment to say, Nike, I am looking for sponsorships in case you want to get on the Superposed bandwagon. And for those of you who are interested in how researchers actually prove that decision-making possesses quantum-like contextuality, I'm going to point you to the 2018 article entitled Snow Queen is Evil and Beautiful, Experimental Evidence for Probabilistic Contextuality in Human Choices by Cervantes and Dazarov, which showed in a simple decision experiment that people's choices under different contexts showed interactions that couldn't be explained by direct interactions, that the effects had to come from the context of the experiment itself. Which is actually a great segue into our frontiers and our fourth pillar of non-communicative effects. And this represents the absolute frontier, the cutting edge of what researchers are discovering or even contemplating about our own minds. Now, I want to be clear that some of what I'm going to be talking about is research-based and evidence-based, and some of this is just speculation or my own thoughts, and so I'm going to do a good job of distinguishing between the two, but also keep in mind that these are very active fields of research, and all of this could change overnight, should there be evidence provided one way or another. And so let's start with talking about quantum entanglement. Now, whether this is with particles or decisions, the concept of entanglement really just means that there are interactions occurring in a system that cannot be described by the direct influence of the different elements on one another. So in a really simple example, say that you're sitting in a room full of people. If you were to raise up your glass and someone on the other side of the room who can't even see you also raises up their glass, that is in essence what entanglement is talking about. That there is some interaction between you raising your glass and the other person raising their glass, even though that there's no direct interaction between you two. Now, the way that researchers test the entanglement is through something called Bell's bound, or the Bell's threshold. And what the Bell's bound really describes is the theoretical maximum direct interaction and correlation that two elements can have on one another. And so if it is found that Bell's bound is exceeded in these interactions, it means that there are effects taking place that are beyond the scope of direct interaction between those two. And this is actually how researchers first provided evidence that contextuality occurs in decision-making systems, showing that people's decisions under different contexts exceeds Bell's bounds, meaning that the context itself, the only variable that's changing, must be producing the different results. And so with that, let's talk about the order effects. And so order effects are another type of non-communicative effect, which simply put is the non-classical interactions that the order of information entering the system has on the superposition. As researchers since the 70s have demonstrated order effects in little examples like this. And actually, this one is taken directly from a 2002 Gallup poll, and feel free to answer as you like, but time has changed perception of what I'm going to be talking about here. And so in your mind, just think yes or no. And the first question is Clinton honest? Is Gore honest? And then that's going to be compared to, is Gore honest? Is Clinton honest? And what Gallup saw and what researchers have shown is that the probability of people saying that Clinton's honest or is Gore honest is directly affected by the order that the questions are posed. Other interesting order effects have been demonstrated with medical professionals giving different diagnoses based on the order of different information that is given to them. Even though the information is the same, just the order that is given to them produces different diagnoses. And another interesting case is in mock juries, the verdict that is given is also dependent on the order of information that is given to the juries. Even though it's the same information, the order in which it's given produces a different verdict. And so while these effects have been known for quite some time, it has been hard to test these rigorously before quantum cognition because different classical models just didn't represent those non-communicative effects natively. Now, I like to think about these order effects professionally, especially when interacting with people and double especially in hard conversations. Take some time to think about how the presentation of information can change the outcome of the conversations you have. And it's seen in quantum cognition. Another tried and true non-communicative effect is something called measurement effects. And this is actually a big worry in the research community right now because it's been shown that even measuring an experiment can affect the outcome. And this isn't just in physics, this is across the board, psychology, quantum cognition, etc. And in quantum systems, where the states are based on probabilities, the mere observation, the decision, the questions, priming, etc., of the system affects the end outcome. Meaning that even watching someone make a decision or asking a person about their cognitive processes can massively impact what decision they're going to choose. Now, I like to see this in myself. If I'm having a bad day and I don't really know why, then I'll just go out and say I'm having a bad day and I don't know why. And something crystallizes inside. And all of a sudden, I can start to see what is leading to that bad day and then how do I fix it. And so I'm kind of curious if you've ever experienced something like this or if you give it a shot if you have similar experiences. And so really the mechanism behind the measurement effect is that a measurement collapses the superposition sometimes before a decision is even made. And so it's this premature collapsing of the different options in the superposition that leads to decisions that people may not normally make. And so we're going to talk about quantum tunneling real quick, and this is going to be our last non-communicative effect. And there's also no research to support this, but I think it's a really interesting forefront of what we could be testing in quantum cognition. Now, quantum tunneling is an effect of elements of a system being probabilistic in nature. And to use straight quantum mechanics, a particle, as we think about it, like an atom or an electron, is only a particle when we measure it. In actuality, it's a probability wave that, think of it like a cloud of possibility of where that particle might be when we do measure it. Now, these clouds of possibility, or these particles, can sometimes come up against hard barriers that bounce the cloud back. They just can't pass through it because these are hard barriers. And think of this like a big fluffy ball hitting a wall. It's just going to bounce right off of it. But when the cloud hits with enough force, or that barrier is just weak enough, or you do it enough times, then the probability wave actually seeps through that hard barrier, and there's a non-0% chance that the particle ends up on the other side of that barrier. And so in quantum cognition, I personally think it'd be interesting if we can observe whether or not a superposition coming up against a hard context barrier can sometimes have a non-0% chance of overcoming that context barrier and therefore producing a decision that otherwise wouldn't be made. And so this would be observed as extremely irrational, delusional, or downright crazy decision-making by people, as seen from the outside. And so again, this is just a thought experiment. I definitely want to hear what your thoughts are in the comment if you think this would even be worth looking into. This might look like something like being back in the shoe store looking for size 12 men's running shoes, but for some reason you're buying Crocs for a toddler, even if you don't have kids. And so in that superposition that we've already limited because we're in a set context, those are hard barriers, but the superposition state is nothing more than the probability of certain outcomes being chosen. You're bumping up against that size 12 men's running shoe barrier, but I wonder if there's a way that tunneling, it produces that really odd, irrational choice of buying Crocs for a toddler that you don't have. And this is also just my opinion, but I wonder if any vertical mobility in our socioeconomic structure might be due because of people making decisions at the very edge of contextually what their superposition, quote unquote, should be, enough times to where it tunnels on the other side and they take an insane leap of faith. And again, I want to hear your thoughts on this idea of decision tunneling because I think it might help us explain a lot of the irrational choices that we make. That concludes our look at the non-communicative effects in quantum cognition as they stand today. Again, this is a very active field of research, and so I expect to do a update episode. So briefly just wrapping up here, I hope that you enjoyed this deep dive into the elegant field of quantum cognition. We saw how quantum cognition differs from classical theories and classical models by modeling cognitive elements as a quantum system and thereby natively handling uncertainty and probability, which provides a much more explanatory, unified, and illuminating tool to study the mind. We also discovered that quantum cognition can be applied our logical fallacies and rational decision-making, being able to test how different elements of a decision change the outcome, potentially providing better predictive models for people's decisions, being able to model social and group decision-making, and is even being used today to better influence machine learning models and different data science and AI applications. Additionally, we learned mechanistically how superpositions, interference, and contextuality function. And we saw this with our different ball and string state vectors, as well as our wave pool models. And we concluded by observing some of the frontiers in quantum cognition, especially those applied to our fourth pillar of non-communicative effects. If there's one thing that I want you guys to take away, is that the true power of quantum cognition comes from its ability to be able to accurately represent the different forces in our minds that produce different decisions, not based on certainty or absolutions, but based on probability. But hey, if we've learned anything today, is that being a nerd is just a glorious, glorious thing. And on that cheery note, check out the Superposed Substack for more, and check out next week's episode on how FIFA chose North America to host World Cup. Because it's going on, we're getting in the spirit here. Please in the comments below, let me know your advice on how to make Superposed even better, what's working for you, what's not. If you're telling me to stay off YouTube, I wouldn't blame you, but we're here to stay. And as always, the decision is in your hands. Thank you for listening to Superposed. Aiden out.